we live? Are we live? Let me check. First and foremost. I think we're live. They are live. They are live. We are alive. Let me just increase the font size a bit and then increase this font size also because you know, you won't be able to see anything. Font size is going to be around 20 px. Yes, px. Can you guys hear me? I'm just gonna increase this a bit because I'm just on my phone. Okay, I think we're good. Let's get started.
I have a really terrible sad excuse of a diagram here, but essentially what we need to do is we need to create a bunch of vertex data. And so our program will create some sort of list of floating point numbers. And then what we have to do is we have to load those numbers into a GPU buffer. And then what we have to do is essentially tell the GPU what all of these numbers mean. So in this case, what we would do is we would take a list of floating point values. And so in this case, what we would tell the GPU is that this block of data is a bunch of floating point values where each pair of 2 is a position. And then when we're done with all of that, we can pass it on to the shader pipeline in the GPU. And so this is a diagram from Learn OpenGL.
Because I was doing my research before watching this part of the video. Yes, I'm sorry for the white background. I think he has he customized his browser basically. I need to also add that it's a dark mode extensions, right? It's a dark mode type of thing. I don't know. Let's try to find this. Dark reader. Yeah, let's just try this. Add to Chrome, yes. Extension. Be nice. It has been added to say there we go. Yes. So here's also dark mode. I don't know. Oh, I'll say. So this is a list of vertex data that we're gonna choose. Then we're gonna pass it through the GPU. Where a shader is a small program that runs on the GPU. The processing cores run small programs on the GPU for each step of the pipeline. So each step. These small programs are called shaders, which are basically these steps. I think so. From what I am not understanding. Yes.
.com, which shows the whole GPU pipeline for rendering. Now don't worry, we don't have to build all these from scratch. A lot of this is actually done for us. But basically, it will take in our vertex data, and then the vertex shader will handle the actual positioning of these vertices. And then the fragment shader, which is the second shader that we're going to write, is going to handle the color and appearance of the final output of all.
Yeah, from that website also, we only need to... We're almost going to be working the vertex and the fragment, the actual vertex data, or you could say the vertex shader and the fragment shader.
All of these triangles that are being drawn. So that was a quick overview, but I think that's enough to actually go ahead and get.
Let me also, I'm gonna do this a bit for this video because I don't know anything and we're going to go in the depths of it, you could say. I'm going to try to what the fuck? I'm going to try to, how do you say that? Do it in the opposite direction. Instead of me going and learning about it, like just simple Google searches and like what is the shader, what is the render, what is the, for example, I'm gonna like see the video and then go back a bit from when I understand what is this about, and I'm gonna take notes about it.
Get started. So the first thing that we have to do is,
let me just open this for like, I don't know, let's just open this.
We have to create our chunk of data that we want to draw. So what I'm going to do is inside of our init function here, I'm going to create a block of floating point values that is going to represent our x, y, and z coordinates of a triangle. So I will create our vertices like this, which is going to be an array, and we're going to need 3 points for our triangle. Now these points are going to be a little bit awkward to write because the coordinate system for OpenGL and other graphics APIs is a little bit weird coming from our own perspective here, because the center of the screen is the position 0, 0, and then the top right is 1, 1, and then the bottom left is -1, -1, which is a little unintuitive for at least me personally, but it's made like this specifically because it makes it a lot easier for 3D applications.
Yeah, by the way, it's on GitHub. So I changed the make file. So I wrote my own make file, then asked Claude to help me also make it work on Windows systems. And basically, from what I can see from the Sokol underscore app.h file, we're able to do that. It's like, you could say, compatible with, it's cross-platform in a way. Yeah. OpenGL, I think so. I don't know. I don't know. Yes, OpenGL Spark. No, I didn't do anything. Spark. Okay. I don't know. How do you like put it more black? We'll override website. Okay. Yes, this is much more black. I mean, it's a bit like, okay, it's okay, it's okay. So it's a bit maroon, but I don't know. So instead of bluish color. So markers have no producer. So it's gonna work. It's gonna be cross-platform. Well, this is what I was trying to say. It's gonna be cross-platform. So yeah, if you take the correct application right now on GitHub, which is basically, nah, it's not that good. It's not that good. Shit. Will don't do that. Fuck this. So if you take this right now and just like go on Windows environment and then just run it, it will run, it will compile, it will make. For right now, it's just creating this, like it's not transparent, by the way. It's this is near its transparency. Yeah, but this is what like is generated. So we change like a windowing system. Basically, the underscore Sokol underscore app.h is going to basically allow us to create windows, as you can see, and then we're going to be able to like allow communication between our GPU and stuff like that with like SG setup, not SG setup, S app run, or something like that. Basically, that's so wait, just give me a second. So as run by in our frame, then in our init function, then we are like initializing the graphics environment. So, and then this is the state whereby we're changing the state at each frame. We're changing the state. Basically, this is just this part is just updating the state, and I don't know why, but info, like what is info, lsp info? I know there's an lsp info somewhere. I don't know, lsp info. I don't know. There's like a help, like a usually what format is being used and stuff. I forgot. There's no one. Yeah, it's okay. Okay. So yeah, basically this is that, and then what do we have? We have begin pause, and yeah, so pause and finish the record, and then like actually like submit it to the GPU to be able to display the thing. Like the GPU is going to render out the thing. So yes, and then this is again my formatter is fucking everything up, and yeah, so this is where we have arrived, and also I am using, wait, am I using GCC? Okay, I'm using GCC. Let's try to use clan, because I said I'm gonna be using clan. So if we do a make, it's gonna basically make the same thing. So because I said that I said in this notes type thing that I will be using clan, so yeah. So what was it? So vertex data. So this is where we are going to create our vertex data that whether it is going to contain a pair of a list of pairs, a list of coordinates, a list of x and y coordinates, a list of coordinates, a list of let's just write it x and or y coordinates. So data our main function. No, I'm sorry, I did our init function. So here we go, and then so yeah, so it's okay.
So let's go ahead and actually, which is a little more OpenG, our x, y, and z coordinates of a triangle. So I will create our vertices.
So different graphics is OpenGL a graphics API? You could say yes, it's like you could say like a Vulkan. What is Vulkan? What is the difference between what API is better? Vulkan is technically better than OpenGL. It's going to be high performance and much better. I think Minecraft is Minecraft switching to Vulkan. Yeah, switching to Vulkan. Yes. It's active, I think. Like usual ones. Working good. Yeah, I think they currently the beta testing, or like I don't know, the Vulkan thing for Minecraft is the version that uses Vulkan is like we're not getting like instead of getting 500 frames, you could say you're getting like maybe 420 or something like that. but the 1% lows are better, so it's less stuttery. I would take that over the highest FPS, to be honest, because then you could have like things like distant horizons with the massive render distance stuff, and that would lower the, like, you know, the stutteriness of it. So yeah,
sees like this, which
yeah, we were talking about the coordinate system. There's different graphics API uses different coordinate system. I said I was going to remove this API, so like yeah, but yeah. What the fuck is this? Dark math is hands. So what do people say about this? Oh no, I don't know. What do people? No, it's just comment. I don't know how to do it. Fuck off. OpenGL is right-handed. Why is up? What do you mean right-handed? Left-handed? What? Oh, like a 3D coordinate system, like the X, Z, Y, X, Y, Z axis, like the Y, Z, and then it's like on the right side of that. So it's like this. I don't know, something like that. Okay, I don't know, but so Z is up, Y is up. So right-handed, left-handed. So what does that mean, right-handed, left-handed? So that's down, X is here. The fuck are right-hand rules? I know the Fleming's left-hand rules. Oh, it's the same thing. Like, yeah, Fleming's left-hand rule. It's not the solenoid thing for the magnetic. I did in like grade 13 or something like that. Fleming's left. So it's good. So it's very nice. This warning. So different graphics systems slash APIs have different coordinates systems. Do give this a read. I teach high school game design. Yeah, it's actually like great. I understand a bit of things, you know. It's nice, logical. Yes. So yeah, so do give this a rate and different coordinate system. For example, as coding with sphere will showing us in the video. OpenGL uses places the origin in the center of our screen. This means that for what did he say about it?
The color and appearance of the final output of all of these triangles that are being drawn. So that was a quick overview, but I think that's enough to actually go ahead and get started. So the first thing we have to do is we have to create our X. Now these points are going to be an array, and we're going to need 3 points for our triangle. Now these points are going to be a little bit awkward to write because the coordinate system for OpenGL and other graphics APIs is a little bit weird coming from our own perspective here, because the center of the screen is the position 0, 0, and then the top right is 1, 1, and then the bottom left is -1, -1, which is a little unintuitive for at least me personally, but it's made like this specifically because it makes it a lot easier for 3D applications.
One is at the top. 1 at the top and minus. Wait, how would that look like in a so 1 is at the top? Wait, what the fuck? What? If this is 0, should this not be 1? Nah, it's different. It's because of the translation from 3D to 2D pixels. This means that for this weird system, this means that this weird system of having like what? Okay. 1. What the fuck is? I think it's a bug. Oh, I'm gonna get that. Of having so you could we could just use this. I can't type for some reason. 1 at the top of right corner, and -1 and minus 1.0 to -1.0. The bottom left corner means that it's easier for making things like for making 3D things. I know the English is bad.
So let's go ahead and actually write in these coordinates. So I'm going to do 0.0f for the x value, and then I'm going to do 0.5f for the y value, and then I'm going to do 0.0f for the z value here. And I'm going to put a comment here that this is the x, this is the y, and this is the z. And this is our top coordinate, like this. And let's just make our other entries here.
I need S.Sunhaloo. I need my S.Sunhaloo. So if this is origin, you know what? Let's use lines. So where's the snapping option? Fuck. Oh, it's right click. Fuck. Snap to objects. Double grid. So where is 100? This is 100. 100. 200. So if this is like, let's do this. Something like this. Okay, it's not good. So let's just do this maybe, and then we just do this. Control, like, can we flip this? Flip. I mean, it's not gonna flip Just fuck this. Delete, and then just do something like delete. Just do something like this. Okay, and then here, so here we're going to have our origin, and here's 1 1. So let's do a dot here. So a dot here. We know that. Okay, let's snap duplex now, and then we know that this is like the origin. And then this is 1 1. Let's just write 1 0 1 0 here. And yeah, so now what we can do is we're going to say it's 0, so it's 0 0, so it's going to be starting here. So it's, let's just do something like blue for the top one. So 0 0 and 0 0.5, so x, y, and z. So where's the like OpenGL axes? Oh so the x, oh my god, the x is actually here and the z is like this. So wait a second, so if he did something like 0, so it's like in the middle, the dead center, 0 0 0, and then the y is like a bit up, and then z is like, okay, so it's something here, something here. Let's just do this. Okay, let's just do something like this. Control Z, control, okay, control this. Just do some, I don't know what I'm doing, so yeah, let's just do something like this, and let's color it blue. Okay, and then this is the top coordinate.
Now I'm going to make this go clockwise, so I'm going to make this one 5, and then the y value is going to be negative 0.5, and then for the third coordinate, it's going to be the bottom left one, so it's going to
wait, negative 5, so 5 is like here, so we're going to be like going here, and then like negative 5 is like here, so like here. Oh, so it's okay, I get it. So we're good, we're doing good, brothers. Good. So it's like 0 0.5, and then here it's like 0. Okay, fuck. So 1 to 2. Okay. So 1 2, and then 1 2, so it's like up a bit, and then here also like we can do something like this. I don't know, just doing things, you could say. So let's just red, blue, green. So let's RGB G, and then let's, I don't know, B. So this should be, so we could say that this here is like 0 0.5, 0 0.5, and then minus 0 0.5, and then 0 0.0. It's not really 0. I mean, on the, so 0 0 for the x means that it's just making a 2D image. So it's just making a 2D image for the moment. So because the z is like this. So I'm just gonna make a like a little like thing here, like a key here. So here, and then here, and then here. So how do you, wait, what? I forgot now. I forgot how to do. How the fuck did I cancel this? Wait, it's been so long since I haven't used Excalibur, I forgot. The fuck? So, yeah, so this is like the y-axis. Okay, I'll fix it later. Z-axis, and then this is going to be the x-axis. Oh, very nice. The x went right there. Okay, so we are Gucci in terms of this, and then we can group this. So group selection, and then we could just simply move this around like here, like a key here or something like that. So the OpenGL coordinate system is like this. And then how do you see that? So you could say that we are not using any like Y, I could say. So it's only like 2D plane because this the Y is like there. So I could just increase this a bit. You could say increase this a bit here. I don't know. It's not too big. So like that, and then this is it's good. It's good. It's good. It's good. It's good. It's good. Yeah. We should increase it a bit. Fuck. That's too long. That's what she said. Okay, so very nice. Very nice. Because I can see like the three-dimensional aspect of it. I mean, we could do something like this. Oh, fuck. So we could have a 3D. Sorry. And then this is going to be 0 and 05. Yeah, am I right? Yeah, 0, 05. And then this. Whoa. So, yeah, so 0, 0 0.0, 0 0.5, and then 0 0.0. So this is the coordinate system for this one, and this is the coordinates for this one. So I'm just gonna plonk that down here, and then so we have the first one, the second one. So let's just do like a 1 here. So like a little 1, like a small one. We'll do that later. So a 1 here, and then I think I can just like do something like Control D, and then just like move this around. Nice. And then this can go right over here. So here it's going to be minus 05 and minus 05. I think so.
To be negative 0.5 and then negative 0.5. Okay, and so now what we need to do is we need to actually put this data into a vertex buffer. Now Sokol.
So wait, we just made this. I think I'm gonna save this. I'm gonna toggle the fuck. I'm gonna save this. Wait, what the fuck was that? And then I'm just gonna this thing over here. Okay, so we have our mathematical thing. We could just click on this, and RGB, and then we could like do like a line here. So we have a triangle. So we could say we could do something like this, a line, and then from this line we could like have something like this. I don't know what I'm doing. So just something like this, like white. So dead center in the middle. And then dead center in the middle also, like here. And then we could like Control D this, Shift H this, copy this, paste this over here. And then we could do something like a simple thing like so we're gonna just do something like that. That should be good. I think so. Yes, very nice. And there we go, we have our triangular activities. The background is going to be the white background. I'm just gonna copy this. Just gonna paste this over here. Let it be. Fuck. It's my phone. I'm sorry. It's my phone and my friends. here is going to be a duplicate, and it's going to be Control Z, and it's going to be an enter here, a 0 and a 0 here, and then we have our like little like thing here. So this is the coordinates, yeah. And then so I'm just gonna save this. No, not save this. I'm gonna export this. Windows Control Shift E. I don't know. Export it with Control Shift E, and then I'm gonna explain as the background as a dark mode. No dark mode, please. So, and then save as a PNG. I'm gonna say open GL hello triangle coordinates. Control E, Control C. Save this, and then I'm just gonna Control P. And I'll change the length of this, and yeah, it's nice. So I need to do that because when I git pull on my Windows system for my Obsidian Vault, it does not, because it doesn't allow for like extended length or something like that. So I just like, I know you can configure that on Windows, but given that I just play on Windows, I don't care. I'm not gonna spend my time configuring Linux and then configuring Windows. For example, all my configurations are done by WinHounds, so I'm not gonna like waste my time on things like that. So yeah, so where were we? Yeah, I've stopped using this. I don't know, stop using this because I don't really use this, and the size doesn't really appear. Oh, it's we'll see. I can always change it back to here, We'll see. Oh, but yeah, you get the thing here, so why would you like do instead of here like that? So downloads folder, and so GOSU no media, and then images, and then programming projects, programming languages, Odin project. The fuck am I going to do that? How? I'm gonna make another like projects, and then I'm gonna say Sokol 3D model viewer. And again, I'm gonna have to Control C this, Control V here. So Control A, Control X, Control V. And first of all, model. So Control P. Length of you know what? Let's just copy this. Length of this plus the length of what? What does this give us? Very nice. So here we go. We can add that over here. So update our in function to add our list of vertices. So pairs, like coordinates. And list of vertices. I will know list of vertices. So I'm just gonna like function to initialize. Where did he put that? He put that after the setup, obviously. So initialize. So triangle coordinates and third coordinates. Array to hold coordinates for triangle. You could say like float vertices, and then you could say something like that. And here we're going to have our first vertices, which is going to be so it's only an array. It's only a list of because it's not a 2D array, this one. Oh wow. Okay, I get it now. I think so. So 0.5 f and then 0.5. No, it's 0.0 this time, right? Yes, 0.0 and then 0.0 f, and this here and do, and I'm just gonna do something like x, y, and z. Nope. And then I'm just gonna do something like so remember the same as him, top coordinates, top coordinate, and then what do you say? So 0. So below, so 0.5, 0. minus 0.5, 0.5 f, 0.5 minus 0.5 f, and then 0.0 f, and then this is the top coordinate, this is the bottom right coordinate, and then minus 0.5 f minus 0.5 f and 0.0 f. So this is the left bottom left coordinate. So he knows his coordinate system well, huh? The guy knows his coordinate system very well. So here we have it nicely. It's yeah.
Sokol has a data type called an SG binding, -0.5. Okay, and so now what we need.
So here we have our vertices. I'm just gonna do here. I'll do some main system. This goes just after the SG score setup function. So here we go. Visually this looks something like this. So what do we do? There we go. Usually this looks something like this, and what I can do something like 500 to make it smaller. It's still it's nice. So something like this works. Very nice. So here I think I'm gonna go for 600. 655. What the fuck? Okay, it's okay. Now what are we going to do?
And then for the third coordinate, it's going to be the bottom left one. So it's going to be -0.5 and then -0.5. Okay, and so now what we need to do is we need to actually put this data into a vertex buffer. Now Sokol has a data type called an SG binding, which we're going to be using here. So I'm going to call this my binding. And so now we can go down here and we can say state.binding.vertex buffers. And if we look at what vertex buffers is, it's basically 8 buffers of data. So we want to use.
So we need to pass this data and allocate. So we need, I think first of all, we need to allocate a space for the buffer. So in our GPU, so in this case, it's going to be the vertex buffers. And then we need to pass the vertices data to that buffer. I think so. Let's go back and listen to it.
0, and then the top right is 1 1, and then the bottom left is -1 -1, which is a little unintuitive for at least me personally, but it's made like this specifically because it makes it a lot easier for 3D applications. So let's go ahead and actually write in these coordinates. So I'm going to do 0.0f for the x value, and then I'm going to do 0.5f for the y value, and then I'm going to do 0.0f for the z value here. I'm going to put a comment here. This is the x, this is the y, and this is the z. And this is our top coordinate, like this. And let's just make our other entries here. Now I'm going to make this go clockwise, so I'm going to make this one 5, and then the y value is going to be -0.5. And then for the third coordinate, it's going to be the bottom left one, so it's going to be -0.5 and then -0.5. Okay, and so now what we need to do is we need to actually put this data into a vertex buffer. Now, so
What's the vertex buffer? So where does that vertex buffer come from? So vertex buffer. You know what? I have a new name, so specify vertex underscore buffer. The readme has a vertex buffer. So where readme? Make buffer. Sokol shape. Nuclear. I think it's GFX, I think so. I don't know, man. I will have to just code it, I guess.
Sokol has a data type called an SG binding.
So the SG binding is in the Sokol, so NV specify SG underscore space, so SG underscore bindings should be in the GFX.
Which we're going to be using here. So I'm going to call this my binding. And so now we can go down here and we can say state.binding.vertex buffers. And if we look at what vertex buffers is, it's basically 8 buffers of data. So we want to use the first buffer. So we will go to the 0th index. Then we'll use a function called sgMakeBuffer like this. This takes in a buffer descriptor. So I'm going to do SG buffer descriptor here, and what we need is we just need to basically just pass in that data, and what this will do is it will take that data and it will upload it to a GPU buffer. So we'll do data equals, and we need to essentially wrap this in something called an SG range, which is a nice little convenience macro that turns our stack allocated data into a piece of data that has a known size. And because I don't like magic, let's go ahead and look at what this macro does. It's really nothing crazy. All it does is it creates a new SG range object, which this struct basically has the actual data and a size associated with it. So this is essentially like a slice type if you're used to something like Zig or Go. So it's basically just a chunk of data.
What is a slice type in a fat pointer? Oh fuck. What? Oh my god. What is a fat pointer in programming? What is a fat pointer? A wide pointer, okay. Data structure that pairs a raw memory address with additional metadata. While a simple only points to a memory location, a fat pointer bundles that address with extra information required to process and safely access the data. Is a data. Okay. Okay, Mr. Data.
data with a known size associated with it. Be careful with this because this doesn't really work with heap allocated stuff. So because this is on the stack, we can make use of this, which is very, very convenient. Okay, and that's all that we need to actually get our data onto the GPU.
So yeah, putting our data onto the GPU. Now, given that we now have created our data slash coordinates, a list of coordinates, we need a way to send that to place that data onto our GPU. Therefore, we need to allocate a bit of space on the GPU for our data and actually place it there via memory addresses. Meaning we are going to use Sokol plus CIPT 2 T2 meaning that we are going to use pointers. Yay. Okay. Fuck. It's closed. I don't want to waste my, Okay. I have arrived at the point in the video whereby I have understood the open real coordinate system, meaning that the x-axis where the x, y and z axis are located at, and also have created a float array that holds the three coordinates data for the individual points. Now so space FL and so what do you say? So how did you write that? Vertex buffer. So bindings dot vertex text dot buffers. What the fuck? Okay, space FL a vertex underscore buffers. Readme, yeah. Stated bind. So readme so the bind is a where's the bind here? So bind is a, like, you see binds. So a bind is binding, so as the range data. So yeah, okay, this is what I have followed and done in terms of code. Right, so this is going to be here, and then here. Now I have a question about buffers and actually placing that code data, it says, onto the GPU stack. Oh, what the fuck is happening? Stack. And the GPU is like a memory, stack. Yeah, so on the GPU. So here is the code that I found on the this is the code that basically is I found on the Sokol's readme.md file. So here's this one. What does the above means? Does vertex does this means that we are creating space on our GPU to place our data? Oh, it's a make buffer. And so estimate buffer means creating space on data and then placing it immediately, and then placing / sending it immediately onto the GPU. Or do we simply just send it to the GPU and the GPU will try to find space for it? I know it's a dumb question, but still better than no question. What the fuck? Oh my god. Joking me. 5:30. Oh my fucking god, I'm going to ChatGPT. ChatGPT.com. Oh my fucking god. So I want. Oh, wait. So let's just place this over here, for example. Fuck. No fucking shit, bro. And then I'm just gonna take this, go up and up and up and up and up and up, copy paste. Yeah, sorry, I've already talked about this, so yeah. My god, bro, I'm just gonna. This is what I don't. Bruh. Yes. I'll be right back. This is what I'm basically doing. I'm doing this for a friend. He wanted to see how I actually like code in a way. Like I don't spit everything to AI. Like for example, I have not used AI that much. I'm just asking it questions and it's answering me in a like instead of me trying to go to Reddit